Hi guys, this is review of unit circle trig. This video is intended for calculus students that may not have learned or have forgotten. So everything we do today, it is related to triangle trig that you know from geometry. It's just a little more efficient and it makes a few more connections as we're doing calculus. When I refer to trig throughout our AP course, I will always refer to a unit circle. So first thing, when we're on a unit circle, it's called a unit circle because its radius is 1. So everything we do today, you know that this is a distance of 1. This is a distance of 1. This is a distance of 1, but it's in the negative direction. So just keep that in mind. And this distance here is also 1, but it's in the negative direction. So let's think about this on a unit circle. If we were to think of the points going around the circle as coordinates, then we know that this would be over 1, up 0. This point at the top would be over 0, up 1. The point in the far left would be over negative 1, up 0. And the point on the far bottom would be over 0, down 1. These are by far the most straightforward values on a unit circle. Okay. So other things to keep in mind are if we're thinking about this right here, when we think about it, we know that the height going down and the distance from the center to that same point over here are going to be equivalent. So when we start thinking about things around a unit circle, we know that this length here has to be equivalent to this length here. And that is also true in the other quadrants. That makes that pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 really nice values. And you may have already realized that just from the triangle trig that you have done. So let's talk about evaluating on a unit circle. When we think about evaluating on a unit circle, we can find sine, cosine, and tangent using those ratios that we learned about trigonometry. So for instance, we know that sine is opposite over hypotenuse. So we know that the sine is going to be this opposite side over this hypotenuse side. Okay, well, the thing about a unit circle, the beauty of a unit circle, is that hypotenuse is always 1. So if you want to find the sine value for any triangle, whether it be that little one or this one that's slightly larger or this one, in all of these instances, because sine is opposite over hypotenuse, really all we need to know is the height. So that's the beauty of the sine function. And I'll use orange, not yellow, because that's going to get rough to see. But we really just need to know that height. So we know that this height versus this height versus this height versus this height, they are getting progressively larger. So keep that in mind, is that when we think about height, we're always thinking about a y value, right? Versus a width would be an x value, especially when we're on this unit circle. So the height down here is 0. The height up here is 1. I should probably pick a different color. Let me try that again for you, sorry. The height here is 0. The height up here is 1. So we know those heights in between have to be between 0 and 1. In fact, there is a really great trick for figuring this out. I'm going to make this a little bigger so you can see my writing, but I'm going to zoom in just on this first quadrant, and then we'll worry about the other quadrants. So if I think about sine as being height, I can think of this height over here as being radical 0 over 2. And I can think of this next height as being radical 1 over 2, and radical 2 over 2, and radical 3 over 2, and you can see that they are getting progressively larger. And in fact, you can simplify these. Radical 0 over 2 is 0 over 2. So 0. Radical 1 over 2 is a half. Radical 2 over 2 cannot be simplified. Radical 3 over 2 cannot be simplified. But radical 4 over 2, that's just 2 over 2. So 1. Another beautiful thing about a unit circle is that we're going to have all these really nice matching heights. So for instance, that height at pi over 3 here, it's going to be equivalent here because it's that same distance from the x-axis. And the height at pi over 4 is going to be the same at 3 pi over 4 because this is the same distance. And the height at pi over 6 is going to be the same at 5 pi over 6 because it's the same distance. So that means we can easily fill these rest in. We know these are going to be radical 3 over 2, radical 2 over 2, 1 over 2, and then 0. And without thinking all that hard, we can see how we have more pairs. So for instance, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, they all have that same distance. It's just sometimes they're in a negative direction. Oops, sorry about that. And we know that pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, again, all of those angles are the same distance from the x-axis. So they're going to be the same. It's just sometimes they're going in a negative direction. And the same thing happens when we talk about pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So when we start looking at trig from a unit circle perspective, we can start seeing how everything's just cyclic, it's circular, just like a good sine or cosine graph. It has a repeating pattern. So once you see the beauty to the pattern, you're not memorizing. I mean, maybe a little bit knowing that sine is a height value, so the heights are getting larger, so you're counting up. And maybe a little because you're thinking through like, okay, where is height positive versus negative? But it's much less memorizing and more seeing the beauty in the pattern. Okay, so I'm going to attempt to erase these yellow lines without erasing the orange. And then we're going to talk about cosine. So when we're thinking about cosine, and we think about triangle trig that we know and love, we know that cosine is referring to adjacent over hypotenuse, SOHCAHTOA. So I'm going to go ahead and draw that pink back in so we can see that. Here's my y-axis, here's my x-axis, and now I'm going to talk about width. So we're thinking about width. Well, the width from the center across is 1. And then we're going to do that same thing we did before, and we're going to say, okay, this time instead of opposite over hypotenuse, it's adjacent over hypotenuse. Sorry about that. And then for this one, it's going to be, again, adjacent over hypotenuse. And this one is also going to be adjacent over hypotenuse. And when you think about this, you realize that these widths are getting smaller. So the value of cosine should be getting smaller. In fact, the beauty of sine and cosine is when you use these special angles, we're talking about exact opposites because on these triangles, that height and width, they're interdependent, and as one changes, the other changes. So you can see, and I'm going to change to blue now, that the initial width is 1, but they're getting smaller all the way down to 0. So with sine, we counted upward, radical 0 over 2, radical 1 over 2, radical 2 over 2, radical 3 over 2, radical 4 over 2. We're doing the opposite. Radical 3 over 2, radical 2 over 2, radical 1 over 2, which we know is just a half. So I can write it at that. And we can see that these widths are reflected. So this width over here at 2 pi over 3 is the same as pi over 3. It's just in the negative direction. And so cosine, the width is large at 0. So it's going from bigger to smaller at pi over 2 and back to even smaller, negatively so, to pi. And then we're talking cosine, so it's negative in this quadrant because it's just like an x value, it's like a width. Negative down here, and then it's positive. So the orange here are all your sine values, and the blue here are all your cosine values, because it's a great strategy to think of sine as like height in the unit circle, and since that hypotenuse is 1 all the way around, that it's really just your y values. Cosine is like a width, and it's really like an x value. So tangent is really like sine over cosine. Well, not like, it is. We know that from our trig identities, but so it's really like a height over a width, or a y over an x, which should look familiar because that's how we find slope, right? Change in y over change in x. So if we're looking through all these points, let's pick a new color for, we'll use purple for tangent. So at 0, I know right here, my slope is 0. And over here at pi over 4, in fact, all the way from here up to here, it's going in a positive direction. So my tangent, my slope is 1 here and 1 here. And if we think about it this way, my slope is negative 1. And I know this vertical line, this y-axis going through the center, that slope is undefined. Try that again. Undefined. So it's undefined down here also. So that gets us a lot of our tangent. Those in between, we know from using your triangle trig that our two options left are radical 3 and radical 3 divided by 3. Well, this slope is significantly taller. In fact, it's 3 times as tall, right? So this is radical 3, and this is radical 3 over 3. I hope some of these strategies will help you in keeping track of trig. Refer to this as often as you'd like. I'm going to post it in Google Classroom.